On an abacus, there are always 10 beads on a wire, 5 and 5 that we can see here. So there's our constancy. Let's go ahead and look at the number pairs that make 10. 1 and 9 make 10. 2 and 8 make 10. 3 and 7 make 10. 4 and 6 make 10. 5 and 5 make 10. 6 and 4 make 10. 7 beads on the left, 3 beads on the right, always 9 beads on the wire. 7, 9, 10, always 10 beads on the wire. So 7 and 3 make 10. And we all make mistakes sometimes, right? 8 and 2 make 10. 9 and 1 make 10. 10 and 0 make 10. Here's another abacus, and we can see a fun way that students often like to make a design on the abacus. Now we can see 2 triangles, right? And what happens on the left side is the number of beads increases by 1 each time. So that means that since there's always 10 beads on every one of these 10 wires, if the number of beads here is increasing, then the number of beads here must be decreasing, because each wire always adds to 10. So one little game or practice we could do with this is we could say 1 plus 9 make 10. 2 plus 8 make 10. 3 plus 7 make 10. 4 plus 6 make 10. 5 plus 5 make 10. 6 plus 4 make 10. 7 plus 3 make 10. 8 plus 2 make 10. 9 plus 1 make 10. And 10 plus 0 make 10. So to summarize, on an abacus, there are always a total. Notice this is a number bond, and this is the whole with the 2 parts that make the whole. So there are always a total of 10 beads on a wire. So the beads on the left, the number of beads on the left, plus the number of beads on the right must combine to a whole of 10 beads total. So that makes the abacus a really great way for practicing friends of 10. Now, the same is also true of our fingers. Here's another number bond. When we talk about our fingers, we all, hopefully if we're fortunate, have 10 fingers total. So whenever we show a number like 6 or 7 or so on, we put some fingers up and we put some fingers down. Now, those 2 numbers must combine to 10 total, making fingers another great way to talk about the friends of 10. So let's go ahead and look at that now. 10 fingers up and 0 down make 10 fingers. 1 finger up and 9 down make 10. 2 up and 8 down, you can see the 8 here maybe, make 10. 3 up and 7 down make 10. 4 up and 6 down make 10. 5 up and 5 down make 10. 6 up and 4 down make 10. 7 up and 3 down make 10. 8 up and 2 down make 10. 9 up and 1 down make 10. 10 up and none down make 10 fingers. On a 10 frame, there are always 10 frames. There's our conservation. We're never add frames or take away frames. There's always 10 frames on a 10 frame. Some of the frames can be filled, leaving the remaining frames empty. So the number of filled frames plus the number of empty must make 10 frames altogether. Now, hopefully this doesn't confuse anyone, because normally eggs come per dozen, which is 12, 6 on top and 6 on bottom, but I cut off the egg holes here, and this is a great way, just an egg carton, to make your own 10 frame. So here the number being represented is 10 because there's 10 objects, 10 fuzzy balls in the 10 frame. The number represented here is 9, and we can see that 9 filled frames plus 1 empty frame make 10. Here 8 are full, 2 are empty, making 10. 7 full, 3 empty. 6 full, 4 empty. 5 full, and 5 empty. Now notice I didn't have to count all 5 of these. I know that if the whole top row is full, it's got to be 5. I've also memorized that if the whole top row is filled plus one more, it's got to be 6. But if I haven't quite memorized that yet, I can always think, okay, 5 here and 6, or 5, 6, 7, without having to count 1, 2, 3, 4, 5, 6, 7. So that's one way to speed it up. 4 filled and 6 empty make 10. 3 filled and 7 empty make 10. 2 filled and 8 empty. Now notice I know this is 8 as well because I have a whole row of empty here, which is 5, and 3 more. And I've memorized that 5 and 3 is 8. 1 filled and, well, there's got to be 9 more that are left empty. 0 filled and 10 empty make 10 frames altogether. All my examples so far have been concrete, something I can actually touch, or pictorial, like the picture of those 10 fingers. But now I'm going to move into the abstract, the numerals that represent a number. I love that we've talked so much about this concept so far, and we have kept it all out of the abstract, but abstract is valuable as well. So let's say you want to try and list all of the friends of 10. So you can go ahead and think 1. Okay, 1 and 9 make 10. What else? 6. What makes friends with 6? Oh, I know that's 4. And what makes friends with 7? Okay, 3. 7 and 3 make 10. 2 and 8 make 10. But notice what I've been doing so far is writing the numbers a little bit out of order. And so it's a little bit trickier to figure out if I've hit all of them or if there's some numbers I've missed. So I'm going to show a strategy where in order to write all of the friends of 10, I'm going to write the numerals in order to 10. It doesn't have to be in order, but this is what helps me. And actually you can start at 0. So now I know that 0 and 10 make 10, 1 and 9, 2 and 8, 3 and 7, 4 and 6. Now you're going to start to notice a pattern here, just like on the abacus. Since each time we step down, the number on the left was getting larger. Each time we step down here, the number on the right has to get smaller because they're all going to be equal to 10. So without even looking at these numbers, I could, on the left, I could just go ahead and do, okay, 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. And I could slap my plus signs. That's okay, but I prefer the way I did at the beginning where we actually say 3 and 7 make 10, or 3 plus 7 equals 10, and to go along that way. But the way I've shown you here kind of highlights the pattern. And we can do this for any number. So I'll give one more example with, let's say 6. I'm going to go ahead and write 6 at the top so we're really clear that that's the whole I'm making. So I can write my numbers from 0 to 6. And then I know that 0 and 6 make 6. 1 and 5 make 6. 2 and 4 make 6. I could also decompose 6 as 3 and 3. Or if it helped me, I could decompose it as 4 and 2. Or 5 and 1, or 6 and 0. Those are all of my friends of 6. And lastly, there's an idea of having a rainbow, also keeping it kind of abstract, but noticing the pattern. So let's go ahead and write the numbers. I'm just going to leave 1, 5. You'll see in a moment though. So here's the numbers from 0 to 10. So if we kind of make this into a rainbow, 0 and 10 make 10, 1 and 9 make 10. Isn't that cool? So drawing my line from the next numeral in here to the next numeral in here, I'm going to connect those dots. 2 and 8 make 10. 3 and 7 make 10. 4 and 6 make 10. And lastly, 5 and 5 make 10. This also, the rainbow idea, works for other numerals. So I'll give you the example again of the friends of 6. Those are also good to know as well. 0 and 6 make 6. 1 and 5 make 6. 2 and 4 make 6. And 3 and 3 make 6. And as a quick challenge question, I would give you students who are interested the question, which numbers, when we're talking about friends of a number, end up having this little teeny loop inside? where 5 has to loop to itself, or 3 has to loop to itself. But there's other numbers, if we were to make a rainbow to 3 or 4 or 5 or 7, that don't have that loop. So my challenge question is, which numbers have that little inside loop and which don't?